Good evening, everyone. Welcome to a new series. It's helpful for the exams. Today is April 14th, and we have still 15 more days for the exams to go with. And towards it, today I have started with a new series, which is on solving MCQs by looking at the patterns. And I will not be solving the complete MCQs. I will be solving only a part of the MCQs. I'll provide you the clues, or I'll tell you about how to solve MCQs. What are the things that we need to look into when we start solving the MCQs? Because it's a general thing that I have observed in students that when you start solving MCQs, you start solving something like 10 MCQs, 20 MCQs, 100 MCQs, and so on. When you do the 101th MCQ, again you make a mistake. So why is it happening? The reason is because somewhere the fundamentals is incorrect, or maybe in the shortest interval of time that you have, you need to completely understand the problem and then look for it and to solve it. So somewhere when I talk about understand the problem, what is that I need to look at? Because you have only 1 minute to solve a question, and understanding means it can be 1 minute, or it can be 1.5 minutes, or 5 minutes, or whatever it is. So therefore, we need to look at what are the patterns which have been given and what is the question to be answered, whether it matches with the options, and if it matches, then take the right question and come out of it. Right? That's what we need to do. So towards it, I have made a plan of bifurcating or maybe classifying the MCQs into 5 different types. The first type of which I am going to do here is about looking at the clues given in the MCQ. I observed that in many papers, nearly 50% of the MCQs will have clues in the form of graphs, or maybe in the form of the equations, sorry, not equations, that is in the case of the scenarios like diagrams, or it might be something like some free body diagram, something is given, some visual is being given apart from the statement. So we need to understand something from the statement, from the visuals, and then finally arrive at an answer. But unfortunately, what we do is, many of the students, what they do is, they just read the question and then they mark the answer without looking at the visuals. So this should not be done, because visuals is something which provides you a clue. So let us understand how to use these visuals to appropriately select the answers. So that is what this 50% of these questions are definitely coming out from here. So let us see how fast we can do. My aim is to solve these problems within half a minute, but I don't know. Let us see, because in the previous time also when we started it, 1 minute per question. Many questions took a long time. The reason is because I need to explain. It is not just explaining or doing something. I may be able to solve it in 1 minute, but when it comes to a student, you may not be able to solve it in 1 minute. So the interest is not to solve in a half minute or 1 minute, but to see to it that you understand the path of solving. Let us start with this. Now let me start my timer. So here what I'm going to do is, I'm going to read the problem, then explain what I need to figure out from the visual, and then I'm going to use that visual and then say this is how I'm going to calculate. That's it. I'm not going to show you the calculation process, because the solutions for each of these questions has already been worked out. It's available in my website or in my YouTube channel. You can go through the full solution. You can just copy this whole thing. For example, if I want this particular question, so what I can do is, I can copy this whole thing. If you want the full working of this, I can copy this here. Then I can go to my website, or maybe I can go to my, let me go to my YouTube channel. I can go to my YouTube channel here. I can go to my your videos, or maybe I can just click here. Doesn't matter, because for me it works like this. For you it doesn't work like that. I'll click here and then just press the enter. Now you see I've got this, right? So I can click on this and I can view the entire solution.
Meet Snapper, the best screenshot tool for Mac. With Snapper, you can snap screenshots that look professionally designed without...
I'm doing something like this. So what you need to do is, you need to draw a graph to show the variation with time t of the axle. You need to read the question that I am putting it across in the PDF, and then write out the answer. If you are not getting the answer, look into the clue, and if you are understanding the clue, then try to get the answer and then verify whether your answer is correct with this. If it is correct, then proceed to the next question. You need not go back to this question only. And if you do not get the answer, because I'm not showing the full calculation, so then you can go back to this and find out what went wrong, what went right, and then you can solve it easily. Okay. So with this, let me start with the problem. Okay, let me start the timer. With time t of the acceleration a of an object, the AT graph is given. Okay, what is the change in velocity of the object from t equal to 0 to t equal to 6 seconds? Now, whenever an AT graph is given, what can we understand? We can understand that delta v can be obtained from here. Delta v can be obtained. Change in velocity can be obtained. That's what has been asked. Now, how do you find this? Change in velocity is given by the area. So, what you should do? You should find out the area 1 and the area 2, and finally sum up both the areas and finally get the answer. What is the answer for this? The answer for this I have already worked out, should be D. Now let us move on to the next question. An object is traveling with velocity 5 meter per second. Okay, so one velocity v1 is given. The object then accelerates to 15 meter per second. v2 is also given in the same direction. What is the variation with time of the acceleration of the object? Now what is being asked here? Which of this graph is correct? Okay, now these graphs are nothing but note the y and x axis here. Okay, when you start with this, the moment you look into it, most of us will prefer to go with something like this. v1 and v2 are given, why don't I use v square equal to u square plus 2? That's what we think of. But remember that here the acceleration is changing with respect to time. When acceleration is changing with respect to time, then definitely your v square equal to u square plus 2a will not work. So what will work? Okay, it will only, when you have an AT graph, then what do you get? You can only find the area. That's the only thing that you can do here. This area will give you change in velocity, right? Now what is being given here? It is already seen that v1 and v2 are given. That means delta v is given. What is the value of delta v? Delta v is 15 minus 5, which is 10 over here. Okay. Now what you need to do is look at the graph and understand where you get 10 over here. Can you get 10 here? Now you see, so you get half into 10 multiplied by, okay, what is this? This is 5. So 2 5s are 5 5s are 25. You don't get like this, right? So therefore, find out whether in which of these areas you get 10. Finally, you get the answer. The right answer for this one is seen to be D. Okay. Now let us move on to the next one. The variation. The first question, the answer was not D, it was C. Make a note of this. I just looked into it. Okay. Now next. The variation with time of the displacement of an object is shown. Okay, displacement versus time graph is shown. What are the average speed and average velocity of the object over 10-second time interval? Over 10-second time interval. Okay. So what is he asking? Average speed. Average speed and average velocity. So what is that you should do? Average speed. How do you calculate average speed? It is nothing but total distance. Total distance divided by total time. Total time. Now from here, this is a displacement time graph. How do you find total distance? See, from here to here, the total distance traveled is 10 meters. And again, if you see displacement is now like this, which means what? The particle is going in a straight line like this, then it has taken a U-turn here, it is coming back like this. For how many distance? It is for 2 meters, it's coming downward, backwards, right? So total distance should be 10 plus 2. And what is the total displacement? Displacement is nothing but you start from here and you come over here. Don't take the area. See, any graph that has been given to you, your interest is not to find the slope on the area. Some of these graphs might not be without area and slope also. Okay, so this graph especially, whenever displacement time is graph is given, you may, if the velocity has been asked, okay, then you might find the slope. But here it is asked about average. So you should find total distance, total displacement. Total distance you already got over here. What is total displacement? You start from here, go here and come back. This should be your total displacement. This should be your total displacement. What is this now? The whole distance is 10 meters over here. This is 2 meters downward over here. So 8 meters is your displacement. So therefore, average displacement would be 8 divided by whatever is the 10 over here. This should be this divided by 10. Calculate the value. This will be 1.2 and this should be 0.8. Now 1.2 and 0.8, which is the answer over here. The question number is CO. Okay. Let us move on to the next one. Draw a graph to show the variation with time t of the horizontal speed v of the ball while it is in contact with the racket. So this question is from paper 2. Okay, this is not from paper 1. But anyway, let us solve this. So let me tell you what was the question about. There's something like a tennis racket like this, and there was a ball which was coming and hitting it like this, and as it hits here, okay, it goes back like this over here. So he's asking you to draw a graph this duration. So So numbers are not required on the axis of the horizontal speed of the ball, no vertical speed. Okay, so therefore, the moment it hits here, what will happen? The ball will now come to a rest over here, right? It will come to here. That means at t equal to 0, velocity is 0. Then what happens? The racket now tries to push us back because the elastic force of it now tries to push it backwards. So when it pushes it backwards, now what happens? The velocity starts increasing. When the velocity starts increasing, how does it increase? There's not linear increase, but it keeps on increasing in an exponential way. It increases like so. There is no negative over here. It increases like this over here. And then after some time, what happens? The moment the ball comes out of the contact of the racket, then the velocity remains a constant because there's nothing to push there, right? Therefore, it remains a constant. It becomes like this over here. That's it. That's the answer here. A stone is thrown vertically up from the top of a cliff with velocity v at time t equal to 0. Okay. And here this is negligible. What is the variation with time of the velocity of the stone until it hits the ground? Okay. So now it's a VT graph. Now in a VT graph, what all can we find? We can find the area, we can find out the slope, right? Now see, now here when a stone is being thrown from here, what happens? The velocity is now seen to be decreasing. It seems to be decreasing, and as it goes upward, the velocity becomes 0 here. And then as it comes downwards, velocity keeps on increasing. Why does this happen? Because the value of A, which is equal to minus g, is a constant. It's an acceleration due to gravity. Gravity keeps on pulling out downwards. So therefore, what's the value of g here? This is 9.8 minus 9.8. What's the value of g in the downward path? Once again, it is 9.8 minus 9.8. Now, how do you calculate this value of g in a VT graph? You calculate it by using the slope, right? That means the slope in both the parts of the motion of the object should remain a constant. Now, where is it being seen? It is being seen in this graph, right? It is not being seen here. See, here it is decreasing, and see here it is increasing over here. Sorry, it's constant, but it is negative slope, and this is positive slope. This is positive slope. So here throughout it is seen to be in negative. So here you see it's a curve. So therefore this I cannot consider this. And here you see there's a positive slope, there's a negative slope. So therefore this is also incorrect, right? So A is the right answer. So how did we look at it? We just understood what's happening over here and then try to put it across. P and Q leave the same point traveling in the same direction. The graph shows the variation with VT. Okay, again there's a VT over here. What is the distance between P and Q? Whenever there's a speed time graph and they are asked you to find out the speed distance between two, what is that you need to do? In a speed time graph, the area gives you the distance, right? So therefore, first find out what is this distance. Okay, what is the distance traveled by this P, and then find out what is the distance traveled by Q. So you will get this area A1 and you will get this area A2, the whole area over here, the whole area, you will get this over here. Then what is that you need to find? Distance between, which means you just need to find A1 minus A2. When you get that, you get the answer for it. Now what is the right answer for it? The answer for this would be distance between these two would be equal to 40. Answer is 40. I'm not going to show the calculation, do it yourselves. The next, the graph shows the variation of the velocity of an object with time along a straight line. Okay. This question is really confusing. Many of them make a mistake. What is correct for this graph? Okay, many of them think that there is an SHM over here. But read the question once again. The graph shows the variation of the velocity of an object with the time along a straight line. Okay, that means it is not performing a to and fro motion. So do not assume to and fro motion. See, there are some classes, there are some phrases which is being given in your problem. That is what you need to identify. It's a straight line. Okay, so therefore, the maximum acceleration, no, there is no maximum acceleration and all. Okay, you cannot find using this and all. Right, so most of them take this one. The reason is because they assume, okay, velocity is maximum here and so on. Okay, then the average acceleration of the body is the area. Can we find average acceleration using area? No. Using area, you can only find out the displacement. So this is definitely incorrect. Maximum displacement is at Q. At point Q, what's happening? So they assume that this is an SHM over here. So this is also incorrect. Not an SHM. In SHM, probably this could be true because you know velocity. In SHM, so this is also not true. Velocity becomes 0 here. Yeah, velocity is equal to 0. It means the pendulum is now moving to one side. So definitely this is true in SHM. So what is the left out option? B is the left out option. Then okay. Sketch on the axis a graph showing the variation in time t of the vertical component of the velocity vv of the ball until it reaches a table surface. This is again a question from the structured question. So it was something like this. There's a cliff-like thing, okay, and there was a table tennis table over here, and then the ball is being thrown from here. Now there's a what you call a net over here, and it starts moving like this. until it falls. Now he's asking you what happens to the vertical velocity. Why do we get a vertical component of velocity? We get a vertical component because gravity is attractive, right? So therefore, here your velocity was Vx and here your velocity was Vy, which was equal to 0 at t equal to 0. Now as time proceeded, what happens? The velocity started increasing. What is the equation you use? You use the equation Vy is equal to Uy plus Ay multiplied by t, right? So now what will happen here? Uy was 0. What was Ay? Ay was g into t over here. Okay. So therefore, now Vy is now proportional to g. Okay, when I say Vy is proportional to t, what kind of equation do I get? I should get a straight line passing through the origin, right? I should get a straight line passing through the origin. Can I get a line like this, or can I get a line like this, or can I get a line like this? Because there are some values being given here. If the values are not given, then definitely you can draw any line. Since the values are given, you should be very careful. Now, the plot of Vy versus t should be a straight line passing through the origin, whose slope should be equal to 10. See, it's already given 10 here. So, which line will give you 10 over here? This line will give you 10. See, for example, if I take here, this would be 1 and this would be 0.1. Slope would be 1 divided by 0.1, which should be equal to 10, right? So therefore, this line should be the correct line. Okay. So see to it that it should pass through all these lines. It should at least make an angle of 45 degrees. Okay. That's what is very important. Now, a car travels clockwise along a circular track of radius r. What is the magnitude of displacement? X to y. Okay. X to y. See, it starts from here, ends here. Though there is something which is given here to confuse you. Okay. He's not asking you to find the perimeter. He's only asking the shortest displacement. What is shortest displacement? This is r. This is r. This should be used Pythagoras theorem. So this will get r root 2, right? So r root 2 should be 1 c whole here. Then the road from city x to y is 1000 kilometers long. Okay, 1000 kilometers long here. Let me write it down. The displacement is 800 kilometers from x to y. Then what is the distance traveled from y to x and the displacement from y to x? Okay. See, the distance does not become negative. It never becomes negative. So distance should remain a constant. So therefore, distance traveled from y to x should also be the same. So these two are incorrect. Okay. In a table question, so this is what is the advantage. And then next is when you say displacement is a vector quantity. When you go in this direction, you count the displacement in this direction 800. When you count in this direction, it is negative 800. So the answer should be D. Right. Next one. Let us move on. Ball 1 is dropped from rest at an initial height. At the same time, ball 2 is launched vertically upwards. Okay. Now you are dropping it from here and you are throwing it from here. Okay. Now when you drop from here, what is the equation that you are going to use? You are going to use h is equal to uyt plus half ayt square. That's what you're going to do. But what is it asked here? At what time are the both balls are the same distance above the ground? So at some point they will clash if they are the same distance, right? So let me consider this height here. Let me write x here. So whenever there is a graph, there is a situation given, utilize it. Very, very important. So therefore, now what is that you can see? At a time t, this ball comes over here. So therefore, what is the height of this one here? The height of this one should be h minus x. So therefore, it is not h here. It should be h minus x. And what is uy? 0. So this should be equal to half into what is ay? Ay is nothing but g, right? G into t square. So h minus x is equal to half g into t square. Now when you throw a ball, now what will happen? X is equal to uy t minus half g into t square. This is what you get. Now you have h minus x and ex over here. Now how do I proceed further? Now you look at this here. There is no x anywhere over here. So what is that I need to do? It tells me that I need to eliminate the value of x over here. So it's only having h and u. Just add both of them. H minus x plus x. When I do this, what do I get? I get half gt square plus uyt minus half gt square. It goes away. So you get uyt. Xx goes away. You get the answer as t is equal to h by uy. H by u. H by u. Where is h by u? H by u is answer C. Let us go on to the next one. Graph shows the velocity with time t of the velocity of an object. What is the variation with time t of the acceleration of the object? Vt graph is given. Find out the at graph. Okay. So many of them think, okay, how to solve this? Many of them make a mistake over here. Now what you need to do is, when the particle is going like this, see, look at the graph here. So there, what is the acceleration here? Acceleration is very high. What is the acceleration at this point? Acceleration is reducing. What is the acceleration at this point? Acceleration is 0. Again, what's happening? Acceleration is 0. Acceleration is little bit lower on the negative side, and here acceleration is increasing and acceleration is increasing on side, right? So therefore, somewhere acceleration is decreasing, becomes 0, acceleration is increasing. Let me write down acceleration is decreasing. I'll write like this: acceleration decreasing, acceleration becomes 0, and then acceleration is increasing. Now we got a clear-cut idea about the graph. Which graph can it be? Now initially what is happening? Acceleration is decreasing. Acceleration is decreasing. This is your A1. Then acceleration becomes 0. A equal to 0, and acceleration is increasing. That is the negative sign. This is your A2. Right? So we got the right answer. So A should be your right answer. Right? Then the graph shows the position of an object varies with time in the interval from 0 to 3 seconds. 0 to 3 seconds. At which point does the instantaneous speed of the object equals its average speed for the interval from 0 to 3 seconds? What is he asking here? He is asking you, when do we have V instantaneous is equal to V average? Now, how do you find? What is instantaneous? What is V average? How do you find out using this? Instantaneous speed is nothing but you find out what is the speed at that instant, which you can take the positional coordinate x of t divided by the time taken. For example, if I take from here, if I take here, this will be 1 by 0. Okay, position is 1, time equal to 0, which is infinity. Okay, if I take for example here, so see, take some value over here. This could be 1.2 divided by 1 second. I can get some value. This is your V of t. Now how do I calculate V average? V average, what I should do is I should draw the tangent and find the slope of that, right? So draw a tangent over here. I draw a tangent over here. What does it tell you? Which means that the velocity is equal to 0 over here. And let me take up over here. Okay, so velocity is equal to, so I get, yeah, velocity is equal to 0 over here. If I take this one here, so what do I get here? I will get a tangent like this over here. Now drop a line over here and then use approximate value. This is 1 over here. This could probably be 1.5. Okay, 1.5 divided by 1. Okay, I can use something like this and finally get an answer for this. Okay, so not 1.5 by 1. This could be 1.5 minus 1 divided by what's the time taken? Time taken, this could be around 1.2, and where does it intersect? It intersects over here. This could be 0.5. So this will be 1.2 minus 0.5. Do this for every point over here and get the answer. Simple. Okay, and wherever it matches means it need not exactly match. It is closely matching. Okay, then you get the right answer. So this is seen to be found in case of option C. Just a minute, let me verify this. This is your option C. This is your option. Then a stone is kicked horizontally at a speed of 1.5 meter per second. Okay, from the edge. So velocity is given edge of a cliff of one of Jupiter's moon. It hits the. Why does it say Jupiter? Because do not assume the value of A to be equal to 9.8. That's what it tells you. It hits the ground 2 seconds later. Time is also given. Height of the cliff is given. Then what is the magnitude of the displacement of the stone? Magnitude of the displacement. What will happen? This stone will come and fall over here. Right? Now what is displacement? This is your initial point. This is your final point. Now you draw a line like this and you get a displacement. How do you get this one here? If you know this value, then you can use your Pythagoras theorem to get the answer. Okay. So towards it, how do I know this one? This value is nothing but range, which can be calculated by ux multiplied by t. What is ux? 1.5. What is the time here? Is the time given to you? Time is given as 2 seconds, right? So multiply this by 2, you get this as 3 over here. So this is 3, this is 4, this should be 5 over here. Answer should be B. Okay. Then a car travels from rest along a horizontal surface with a constant acceleration. So which means what? A is equal to constant. A equal to constant. When you say A equal to constant, you can always apply equations of motion. What is the variation EK of the car? The distance is traveled. So what you should do? When I said equations of motion can be applied. Now this is energy. Okay. What is energy? Half mv squared. And then this displacement. Which equation can be used? Don't use the equation relating time. Use the equation relating V and displacement. Which equation is this? This can be written as V square is equal to U square plus 2AS. Now here it says rest. Okay, so U should become 0. Now substitute this values and then what do you get over here? You get 2AS over here, right? V square equal to 2AS. Now multiplied by half m V square, half m on both the sides, and thus you get half m 2AS. So therefore, you see, this is your kinetic energy. This should be proportional to S. So which equation? Which means y proportional to x. Which graph will hold good? This should be your graph D, because this